Hey guys, so I thought a video would be helpful to go over this first lab together. So what I did is I went through and I watched the video and I made notes on stuff that I thought would be important, and I made a quiz, a 5-question quiz that I've already posted on the Canvas. It's under assignments, so you have to go to your assignments tab, click on the quiz and take it. It is a 5-question, 10-point quiz. So 5 questions. Each question's 2 points apiece. And there's 2 what are considered essay questions. They're open-ended. It's easier for me to go in and grade them that way than it would be for me to put a specific answer, when you can abbreviate or you can write out the whole thing. And if you write out the whole thing and I put the abbreviation, it's going to count it wrong. So I made it an essay question, so I have to go back in and grade it, is what it is. There are 2 that are fill in the blank. And there's 1 true false. So you should be good. Use your notes, rewatch the video. If you're unsure, pull up your PowerPoint that I posted in the module. Use your resources. I will always let you use the resources in the room. You'll see what I'm talking about when we get into the actual lab. I like to write on the board, and I don't erase the board until y'all leave the classroom. So with that being said, let's kind of go over the questions and stuff in the lab. I'm not going to go through the video. I'm going to trust that you're going to watch the video, or if you're not, you can pause me in my video and watch what you need to go watch. Just know that both of these videos are here for your resources and for your are at your disposal. So I'm gonna go ahead and say that you've watched the video. So if you haven't watched the video, pause me, go watch the 10-minute video, and then come back to me and we'll pick up from where the video leaves off. So describe the substance that you see as you watch the video. So what we're really talking about in this lab is the scientific method. So create a hypothesis, observe, report, experiment. Can the experiment be repeated? Is it valid, or do we need to keep going? So read through your PowerPoint, and that kind of goes over the scientific method. So what do you observe about what you're using in the lab? So the calcium chloride, it's a solid, it's white, it's dense, it's a powder, but it's like clumped together, so it's almost like beaded, but it's not really beads. So write that down. Observe. I just want you to get into the habit of, before you just jump into something, take a look at what you're using so that you know what it looks like to start with, and see how the reactions make it look at the end. So that kind of helps you know what kind of reaction happens. Is it a chemical reaction? Is it a physical reaction? Is there no reaction when these 2 things combine? So, so the calcium chloride it's white, it's solid, it's dense. So next you've got the baking soda. So the baking soda is also a white solid, but it's more of a fine powder than the calcium chloride. Baking soda also doesn't affect you if it gets on your hands, whereas calcium chloride can generate heat when it comes into contact with a liquid. So if you have like moisture on your hands and you touch that calcium chloride, your hands are going to get warm. And we're going to talk about those kind of reactions here in a minute. Next you have phenol red. Phenol red is a liquid, and the clue is in the name. It's red. And it's basically an indicator to let you know kind of if or how a reaction happens. Your paper says water. The video doesn't use water, but everybody knows what water looks like, so I'm not going to insult your intelligence by telling you what water looks like. Next you have questions after watching the video. What specific combination of chemicals caused a temperature change? So there are 2 temperature changes in the video. You've got the combination of the baking soda and the phenol red. And that phenol red turned pink. So that's a change to observe. It turned pink, and it got a little cooler to the touch. So that combination of the soda and the phenol red caused a temperature change. And then you combine that calcium chloride with the phenol red, kind of like if you've got water on your hands and it gets hot. That calcium chloride combined with that phenol red, and it also created a temperature change. But that temperature change, it got hotter instead of cooler. What specific combination of chemicals caused the color change? So phenol red, when it's in the presence of a base, will turn pink, like the video said. Phenol red, when it's in the presence of an acid, will turn yellow. So there are two color changes observed. So when the phenol red combines with the baking soda, which is more of a base, it turned pink. That phenol red, when combined with the calcium chloride, turned yellow because the calcium chloride is more acidic. All right, number 3. What specific combination of chemicals caused the gas production? That calcium chloride and phenol red combined and it created a chemical reaction where an acid was produced, hence the yellow color, and a gas was given off. That gas, that carbon dioxide gas, CO2 gas, was given off when that calcium chloride combined with the phenol red. What gas was formed? Carbon dioxide. I just said that. So the other thing I want y'all to know is the difference between an endothermic and exothermic reaction. Those are kind of important. An endothermic reaction, it takes more energy to break the bonds in the reaction. So when it takes more energy to break the bonds, there's not any energy given off as the excess heat. So it absorbs that heat, and so the temperature goes down. Whereas in an exothermic reaction, it takes less energy to break the bonds. So it takes less to break those bonds. So those bonds break really easily. And there's extra energy. There's excess energy. And that excess energy is given off in these reactions as heat. So when you touch something that's going through an exothermic reaction, kind of like that calcium chloride and the phenol red, it's gonna be hot to the touch. It's gonna be warmer than it was to start with. So endothermic, more energy, absorbs heat, is cooler to the touch at the end. Exothermic, less energy to break the bonds, gives off heat because of the excess energy, and it's going to be hotter to the touch at the end of it all. Carbonic acid was produced in that reaction. That's not a question I'm going to ask you, but in case you want to know. Let's see. I want to make sure I kind of covered everything. I know this was kind of fast, but it was also just me hitting the highlights of the video you've already watched. So if you have any questions, comments, concerns, doubts, fears, anxieties, you shoot me an email and I'll happily answer any questions that you have. But other than that, what I want you to do after you've watched this and after you've done your online lab, I want you to go to your assignments tab in Canvas and I want you to take that quiz. The quiz is open from now until midnight on Sunday. So you have all week to do this quiz, okay? All week. It will close on Sunday night at 11:59. Okay? Again, any questions, shoot me an email. I'll be happy to help. Thanks.